Alright, finishing up part 2 of writing proofs. Again, most of the time, your proofs, you'll be given some information, and you have a clear goal we're going to want to prove, and we end our work once we've proven that goal. I will say if there was some additional information, it wouldn't be wrong. So, just adding that comment here. Additional steps or unneeded statements don't make a proof wrong. A proof is like writing it wrong. Don't make a proof wrong. Proofs are like writing essays. Say you write the perfect essay for your English teacher, but you have 1 or 2 extra sentences. And those 2 sentences, while they fit in the paper, aren't necessary or don't necessarily support what you're arguing, it doesn't mean your paper's worse. It doesn't mean your paper's wrong. It just, they're not needed. It's still a perfect paper. You just got extra information that wasn't needed. Your proofs can have extra information, or you could find other things that are not needed in your proof, and it doesn't mean your proof is wrong. It just means you found something additional. Most of the time, though, if you're dealing with our online tests or anything, they're probably going to have the proof as short as possible. They will not have generally extra steps that were unneeded. They'll generally shorten it down so that you will only have necessary steps. First off, notice that we're given 3 separate things. B is the midpoint of AC, C is the midpoint of DE, AB is equal to CE. In this case, they're putting 2 of those statements on the same line. B is the midpoint of AC, and C is the midpoint of DE. Both of those were given. I personally don't write like that, but you can. You could put multiple statements on the same line if they have the same reason. Now we're looking to talk about midpoints again. Just like what we were talking on this previous side, your definitions go 2 ways. On the previous side, we said R is the midpoint of UV because UR equals RV. We're going the other way now. B is the midpoint of AC. What can we use with that fact? From this first fact, what can we say? Well, we can say, since B is in the middle of AC, either side has the same length. We can say AB equals BC. We can do something similar with the other part. C is the midpoint of DE. We can write another statement here that says DC is equal to CE. We can mark that on our page as well. Again, if you identify something, it doesn't hurt to mark it on your diagram. AB is congruent to BC, DC is congruent to CE. We've got those marked. Notice we had some given statements. We had a definition of midpoints used. And now we've got another given statement. We don't have to use all our given statements at once. We don't have to list them out all at once. Sometimes it's easier if you don't. AB is equal to CE is what they're saying. That was a given statement, so let's look at that. AB is supposed to be congruent to CE. Well, that means I need the same number of tick marks on both of them. CE currently has 2, so I'm going to give AB 1 more tick mark. But since AB had to be the same as BC, we know BC will need another tick mark as well. Visually on our diagram, we've now proven that BC is the same as DC, what we wanted to prove. Notice BC and DC both have 2 tick marks. We just need to show that with some steps. I'm going to say we're going to show it algebraically, but it's not really algebraic. We're not adding or subtracting at all. No numbers are used at all. We just need to think through what we said. AB was the same as CE. I'm going to take that statement here and we're going to work with it. AB, is that related to BC? Yeah. I'm using my goal, what I want to prove, I think of this as a goal, to help me figure out my steps. I've got AB on the left-hand side of an equal sign, and then I've got BC on the left-hand side of the equal sign. That just means I'm going to have to replace AB with BC. Can I do so? Yeah, right here. Because of this statement, because AB is the same as BC, we get to replace AB with BC. We'll say BC equals CE. All we did is replacement. All we did was substitution. And then they go the same way. They have CE on the right-hand side, but they want DC. Well, luckily we've got a way to show that. We know that CE is the same as DC, so they just replaced CE. Substitution is all that happened. Having extra lines in your proof doesn't hurt. We, in this case, have no extra lines. We get to stop because we've shown BC is equal to DC.